All right, hey, there I am. To this video, we're going to differentiate a function involving an exponential function, e to the x. So the derivative of e to the x, this is the best derivative ever, is itself. Now that's pretty interesting, but it's not that useful to us. We're going to do it implicitly with e to the u. U is any function of x. So the derivative of e to the u is e to the u times the derivative of that exponent. So that's as simple as it gets. So whenever you see e to a power, the derivative is e to that power times the derivative of the power. So it is very simple. But the one thing is you have to remember to follow the rules of differentiation for everything. So the problem I have here is a derivative of x squared over e to the x squared minus 1, and it's a quotient. So we're going to use the quotient rule. So here we go. We have the bottom times the derivative of the top minus the top times the derivative of the bottom. And that's all over the bottom squared. So now we're going to calculate the derivatives. So we have e to the x squared minus 1. The derivative of x squared is 2x. And then minus x squared. And now this derivative, the derivative of any exponential function is the exponential function itself. Don't change anything. And then times the derivative of its exponent, which is 2x. Still all over the bottom squared. So it looks like a lot of times with the exponential function, since it doesn't change, it's going to be definitely factorable. So the top has some, usually I'll clean it up, but at this point I see each term has a 2x and a e to the x squared minus 1, so we can just factor that out immediately. 2x e to the x squared minus 1. And then write what's left over. So the first term, we're left over with a 1. The whole thing factored out. Second term, these two factors factored out, so you're left with x squared. That was it, over e to the x squared minus 1 squared. So now that everything's factored and you can cancel factors, well, we can go ahead and cancel this, the e to the x squared minus 1 up top with one of the e to the x squared minus 1's on the bottom. So it would make that a 1 to get 2x times 1 minus x squared all over e to the x squared minus 1. And that is that. So that's not too bad. So checking Wolfram alpha, you may get a different looking answer. So let's look at it. Our answer is fine, by the way. But there's some interesting things that you can do here. I'm going to try there. Perfect. So I'm going to look at what they have. First of all, they factor out negative to make that right here, to make that x squared minus 1. We've all seen that before. It's just usually you have the leading term is positive. That's no big deal. So in terms of this x squared minus 1, though, they just brought this exponent up. And when you do that, you have to make the exponent negative. So since the exponent was x squared minus 1, that's the exponent now. When you bring it up, it becomes negative x squared minus 1, which would be 1 minus x squared. That's where that came from. So that looks perfect. Again, this answer was perfectly fine. It's nice and simplified, but you may see other versions of the answer. So hopefully you enjoyed that as you enjoy all these videos. See you on the next one.